Let's take a look at solving simple logarithmic equations. First, remember the definition of a logarithm, and the definition of a logarithm gives us this logarithmic form. A is the base, x is what's inside the logarithm, is equal to some expression, and if that is true, then you can convert it to make it look like this exponential equation. Remember, a is the base of the logarithm, x is what's inside. What's inside the logarithm has to be positive, so it can't be 0 or negative, and this base must also be positive. Logarithmic form, exponential form. Now, why we care about one and the other is because if you've got a variable stuck inside a logarithm, then you want to convert to exponential by taking that base, raising the other side up on its shoulders, and giving you what's inside, which is then exponential form. And look, the variable popped out for us so we can solve for that variable. Here we have a variable stuck inside a logarithm, so we're going to convert. The base of 5 raises the 2 up on its shoulders to get 5 squared, and it's equal to what's inside, so that gives us x is equal to 25. And you're done. Let's do that again. The x now is in the base. That's going to raise the 2 up on its shoulder and is going to equal 9. So that gives us x squared is equal to 9. Let's take the square root of both sides. That's a quadratic. And when you take the square root of both sides, you get plus or minus the square root of 9, which is x is equal to plus or minus 3. Let's go ahead and check both of those. 3 and negative 3. Remember, when we first started, we converted and got x squared is equal to 9. When we check the positive 3, x equals 3, 3 squared is 9, negative 3 squared is 9 as well, but you have to go back to this logarithm. The variable is not inside this portion of the logarithm, it's the base. And remember, that base has to be positive, and so all we get is x equals 3, and we throw out the other answer. Now, what happens when you have logarithms on both sides? As you can see, we have log base 2 on both sides and something inside each of those logarithms, and what we have is a property that says that if both of those logarithms have the same base, which they do for us, we have base 2, so a is 2, then you can take what's inside and set them equal to each other, so let's do that. We have 3x minus 1 on the left, and on the right we have x. Let's go ahead and subtract x and add 1 to both sides. Gives us 2x equals 1. Let's divide by 2 on both sides, and you get x is equal to 1/2. When you substitute that back into your logarithm, you'll see that you haven't violated any rules. You've got log base 2 of 1/2 here, and we have 3 times 1/2 is 3/2, minus 1 is 1/2, so you have the exact same thing on the left, and what's inside of both of them is positive, so we get to keep the solution of x equals 1/2. What happens if you have logs on both sides and have a constant? Now, if this constant was 0, we could add this logarithm to the other side, and we'd get log of 2x is equal to log of x minus 3, and then we could do what we just did with the previous problem, but that's not the case. We've got an extra number constant here. If we add this guy to the other side, we're still going to have the same issue. You can only equate logarithms when you have a log equal to a log. You cannot have extra pieces hanging around as well. And so we can't equate the logs for this one, so we're going to need some more skills or tools in our toolbox. So if you would like to see that, go ahead and Google solving complex logarithmic equations in my YouTube channel, and hope you are having a great day.